We all know that AI is here and is here to stay, and is progressing at incredible speed. And in the beginning, you really couldn't run any good models at home without your internet connection and without utilizing the cloud service. That is slowly changing, and there are more and more free open source tools to do so. I want to explore that. I want to explore that a bit more and see if we're almost at the point where most people or some professionals can use it at home in their own environment. So I've decided to set up a server and do some testing. It's a broad range of components, and I want to see what we can do with it. For motherboard, we've actually gone with an ASUS Pro workstation. This is the Sage workstation motherboard. It's probably one of the best for what you want to achieve here. It's got a lot of full-size PCIe ports. It's got PCIe Gen 5 connectivity throughout, and it's actually a board that basically fits all the requirements that I have. For CPU, we've gone with the last generation Threadripper CPU. It's a middle of the range 32 cores, so it's a 7970X. It's a powerful chip, but what we need from it is actually less about the powerful amount of cores. We actually need the PCIe lanes to run a lot of devices. For graphics card, we have an RTX 3090, which is a bit older, actually quite a bit older. It's 2 generations old now, but it's one of the first consumer-grade graphics cards with 24 gigabytes of VRAM. And we've also got a bigger card. This is a last generation card from AMD. It's a W7800. It has 32 gigabytes of VRAM. So that's going to be really awesome for those really big models. The main difference here is there are some tools which are more AMD and there are some tools which are more NVIDIA specific, and they perform slightly differently. So we'll explore that a bit later on. For cooling, we got a cooler from Noctua. In many ways, it's because, well, they've got one of the best coolers in the world, but also this particular system is going to be a rack-mounted 4U server, so therefore having a 4U cooler is perfect for the job. For storage, we have Kingston. And we have 2 different types of drives. We have a slower SSDs, just a standard SATA SSDs, and those will be running the operating system, which doesn't really need much of anything. It just needs some storage, and we'll run it in mirrored fashion, so we have backup. As well as that, we have these 2 Gen 5 SSDs. They came out just earlier this year. These are 2 terabytes each, and this is going to be our main workhorse for loading up the models, as well as probably running some VM storage. So this will be really exciting. And lastly, we have our memory. This is the place where we're probably on the weaker side for what we want to achieve. We've got G.Skill memory, so we have 4 sticks of 32 gigabytes, and for a normal consumer system, that would be an insane amount of memory. Most people don't need that. But for a server, I think this is going to be probably a little bit on the lacking side, and it'll probably be one of the items we want to upgrade in the future. But in comparison to what I've used up to this point, on all my current servers, we're only using DDR4. This is DDR5 and it's running at 6400 mega transfers. So it's incredibly fast in comparison to what I've been used to up to this point. Let's start with the build first. We'll get to the testing in a bit. So here we have the ASUS Pro Series motherboard. This is a TRX 50 Sage. And it also comes with Wi-Fi, so it has an incredible amount of connectivity. Also, it can support a lot of power throughput. So much so that it actually has additional connectors for a second power supply. You can actually see they're covered up right now. So these ones here. So in case you wanted to do some overclocking, and also you have additional ports over here to power those PCE slots. So you can really load this motherboard up. You can see at the back, you have only 2 normal USB ports, and the rest of the ports are either 10 or I believe even 20 gig. No, the rest of the ports are 10 gigabit. So all of these are 10 gigabit, which is pretty insane. So you can really load up the connectivity. And because of the design of the Threadripper CPUs and these motherboards, you have no really limitations in terms of PCIe lanes. You can get all the drives and all the PCIe slots loaded up like crazy. In terms of PCIe slots themselves, it has multiple x16 PCIe Gen 5 lanes, as well as multiple PCIe Gen 5 drives. So it's definitely plenty for us. The only thing is this, compared to the Pro Threadripper chips, only has 4 memory channels, when the Pro motherboards have 8. So you can get up to 2 terabytes of memory. Here, your maximum capacity is 1 terabyte, which is still an insane number, even for a workstation. For the CPU, as I mentioned earlier, it's the 7970X, and it's like any Threadripper CPU, it's a beast of the chip. Oh, this is super heavy. And it comes with its own little tool to have it installed. Use the screws on top that are labeled 1, 2, and 3. You need to follow the directions, because there is a very specific amount of pressure required for the CPU to be installed in this socket for it to all work, because it's so massive. Yeah, once it's open, you lift this packet. You also got a little cover, so be careful. Make sure you don't have any bent pins. I actually do have a pin that kind of looked a bit off because this has been used before, but hopefully we have no problems with that. For the main chip, it comes with a little bracket. So what you do, you take out the little bracket from the existing cover. You slot that in. It's a bit unnerving. It kind of just goes in there. And then you just slot it in place and you put the cover on top. Now, make sure to follow. It says close, and literally written here, close, 1, 2, 3. And you just follow that. Yeah, so you screw it in. And you see, it won't let you screw past the point. So it's torque. It has a torque limitation. So once you get to the limit, it won't let you screw further. Perfect. Just so we don't have the cooler in the way, what I'm going to do next is going to install the drives. I'm going to install the SSDs. And for the SSDs, I just need to double check which ones are PC Gen 5 to make sure that I'm getting the most out of it. This board, I believe, has 3 NVMe slots. There you go. So, what we can see here is we got, that's PC Gen 4. That's PC Gen 5 and that's PC Gen 5. So I need to use these two locations because this one is just Gen 4. So this will have the most amount of speed. So we can just use that, and we can just take off the little peel because it will provide a bit more cooling through the heatsink. The one thing that's amazing nowadays with Gen 5 drives, they are no longer overheating like the initial ones did. They're no longer as, fragile, you might say. So that's a good progression. And that's the thing about technology. Just like AI, like anything in technology, if something is not feasible right now or is not good enough right now, give it a few years and you'll be able to use it at home. That's insane, but that's one of the reasons I love what I do. You can experience things which are cutting edge today, but normal, everyday items tomorrow. There you go, we've got the 2 Kingston Fury drives, and they're the Gen 5 drives. That's your 2x2 Gen 5 NVMe drives from Kingston. If you look at it, you can actually see that they have the chips only on one side. These are using, so you can see it has 2 thicker chips and 2 smaller. So we have the controller as well as memory and 2 1TB NAND chips. And they're only on one side, which means it's going to be perfect because we have the heatsink on the top, a bigger heatsink on top that it can soak in all the heat. Slot them in. I also like that we've got a quick, easy installation here on the motherboard. No longer needing any screws or anything else. Just put them on and just screw on the heatsink on top and you're good. Next up, I'm going to install the cooler. So as I mentioned, the cooler is from Noctua. This is the NHD 9 TR5 SP6, and it's made for the 4U chassis. So it's not huge, but it should be plenty. And the beauty is with chips of this size, because you have more surface area, it's actually easier to cool in comparison to the small tiny chips that we have from the normal consumer grade components. So that's actually a massive benefit. For a consumer grade cooler, you would have a massive one. This is quite reasonable in size. And as you can see, it already has pre-applied thermal paste. So it's literally unpack and throw it on. So this is the cooler. As you can see, it's a dual tower cooler. It is still quite solid. It actually is quite weighty. It's using two 90mm fans. So they're not the biggest fans, but you got plenty there. It's slightly angled out to provide more clearance. And it does install sideways, so you need to double check which way they recommend. Actually, yeah, it mounts this way. It actually only mounts one way because of the screw holes. So you can see these sides are angled slightly out and these are slightly in. So these are more tighter together, so you can't flip it back and forth. And you can see they align well with the screws, existing screws on the board. So you're literally gonna install it like this. And actually, funny enough, the color scheme kind of fits in. I like that. I like that the chrome fits in with the motherboard. After double checking the manual, all you need to do is just remove the fans for the installation process. So just kind of use the little clips, pull back on them, take them out. We'll set them to the side. So that's the main cooler. Just a lump of metal with very densely populated fins. Carefully remove the plastic cover. Align the screws and have it installed. And just use the provided tool to do the installation. Noctua recommends going around in a circle and only doing 3 turns at the time to make sure that it evenly attaches to the motherboard, because you want it very, very straight. Once that's installed, all you need to do is install the fans and you can plug them in. So for the fan headers, you might want to prepare ahead of time. So in this case, this motherboard has 2 fan headers just here. So the CPU and CPU optional. I'm just going to use both, even though Noctua actually provides a little splitter cable that you can use, the Y cable. But I've decided I'm just going to plug them both in and just configure them in the motherboard BIOS to make sure that they kind of sync. Yep, that's good now. Before I tidy up the fans, what I'm going to do is I'm going to install the memory, so then I can kind of route around the memory and not be in the way. So for memory, we've got the G.Skill memory. And it's nicely packaged. It's a bit more tight now, but you should be able to fit it in. With this memory, these are quite small sticks, and it's actually probably easier to install them before the cooler, because once you start installing them here, you can't actually tell if you're putting them in the right way around. So maybe install it before the cooler goes in, because they're not really in the way at all. Here, they're basically hidden inside at this point. Yeah, there you go. Let's see. But with this cooler, it fits nicely with no real problems. There you go. So that's 4 sticks in. That's 128 gigabytes of DDR5 memory running at 6400 megatransfers. That's a fast system. Let's get the fans plugged in now and out of the way. That's not too bad. And what we can do with these fans is actually just hide them below the cooler. So we can put this across this way and this one as well. So they're somewhat neat here and they're not really going to cause any problems. There you go. That is a cool looking system at this point. Now, for the SATA SSDs, for now, when we set this up on the test bench, we're just going to put them on the side. When we go into the main case, these will actually go into their own little slot. But for now, as we're going to be testing this out on a test bench, we will just put them on the side. They'll just be done in a more traditional hanging way. So I do apologize for the mess. So here we have two 480 gigabyte SATA SSDs. They're not particularly fast, not particularly big, but they're perfect for what we need them to be. They'll just be a mirrored image of the operating system. We'll probably start with Windows just to test things out, but after we've done the initial test to make sure everything's working correctly, we'll move over to Proxmox. But for that, we'll actually be doing a second video, so make sure to subscribe so you don't miss it. What I'm going to do is I'm going to put this on a test bench. This is just for testing, so it's not going to be a permanent location for this system. But we just want to power it up and make sure things are working properly. One of the nice things about this motherboard, it's not quite SSIB size. It's basically an ATX Plus, so it's slightly bigger than a normal ATX motherboard, but it fits nicely on the test bench like this. So all it is, it has a little bit of an overhang on this end. Nothing too crazy. So in terms of fitting it in a normal case, you could probably fit it in most cases, even if it doesn't technically support it. For power, we've got only one connection, so we don't really need the second one for now. I'm not planning to overclock this particular system, but there is enough juice in this motherboard to do so, no problem. And AMD actually kind of encourages you to overclock these chips. These are, I believe, 350 watt chips as they come out of stock, but you can push 500-600 watts, no problem without overclocking it, and you can push it even further if you were to overclock it. So it's pretty beastly, but for me, the chip here is for the PC lanes, so we could put in multiple graphics cards and do virtualization and testing. So that's what it's for. So we don't need to do anything crazy. That's why we have a mostly underpowered power supply. The main system will have 1,000+ watt power supply, but for testing, we should be fine. Now, let's start with installing just one graphics card, and we'll take it from there. We'll start with the Radeon Pro graphics card. So this is the Pro W7800. It's a workstation graphics card, and I'm really excited to start testing with it and see what we can do. AMD did recently announce their next generation card, and they've also reduced the price considerably for their professional cards. So I'm interested to see how they're gonna perform in the market. The card itself, this is, because it's a workstation card, it's using a standard blower design. So it's gonna be a little bit louder, but what you get with this is a very thin profile. It's a very small card in comparison to even what we have here. We've got a 3090, but this is one of the smallest coolers you could find, and it's already almost twice the size. But what you find interesting is on these Radeon cards, you have 4 display ports, 3 standard size, 1 mini. So no HDMI, so if you wanted to connect this to your TV for some reason, you would need to have dongles, which is probably not what you'd be using. This card did come out at a really expensive price point. Again, workstation cards, they have extra features and they come with an extra cost. One of the main benefits of going workstation cards is this. So as you can see, I've installed a card and I have a spare slot right below it. So technically speaking, if you had 2 of these cards, you could literally put both of them in and you would not lose any PC slots. You could literally have 2 cards side by side without getting in the way of these ones. As a comparison, if I put in the 3090 into the top slot, the next slot is literally obstructed. You've lost a slot, just like that. And that's why these blower style cards make a big difference, because you can actually utilize more of your ports on your motherboard for useful things. So some of these slots could be used for networking. You can install some additional cards. In my case, I'm going to be installing HBA card for storage. I'll be installing potentially even more SSDs in one of the riser cards. So that's why having a card like this is very, very valuable. So next step is I'm going to set this up. I'm going to set up Windows and we can get into testing right now. The system is live now, and unfortunately I had to spend quite a few hours trying to figure out what the problem was with my memory. Only 2 of the 4 DIMM slots worked. Turns out that I had a little blemish on the bottom of the CPU, which basically prevented one of the memory channels from working. After taking it all apart, cleaning it and putting it back together, it's now live. It's running at full export profile, which is 6400 mega transfers, and it's performing really good. Let's check out a few benchmark results. We'll start off with Cinebench. So for this, we're going to do a quick multi-core score test. I'm not going to run single core because this system is not made for gaming. It's more made for processing a lot of data. So we'll do multi-core test. And while that's running, I'm going to open up hardware info just to see the stats. And we can also open up Task Manager at the same time just to see what our performance is on like CPU and cores. Here we can see the cooler is ramped up and we've got around 84 degrees on the core. And the chip is running at 4.6 gigahertz on all cores. Obviously this is going from cold, so this is going to get a little bit warmer. But right now it's kind of in the worst case scenario because it's an open test bench, but with no additional fans like you would have inside the server. And it's also running in our office, which is quite warm. It's around 28 degrees Celsius here. But it's definitely running nicely. It's still got about 4.55 gigahertz speed now. I reckon it's going to probably drop down to around the 4.5 towards the end of the test. But if we look at the results, we are going above 3,000 points right now. Just for comparison, a 32-core second gen Threadripper scored 1.2 thousand. So it's a 2 to maybe even 3x the performance from what it used to be back then. So we finished at around 3.4 thousand. I've ran this a few times and I averaged between 3.4 and 3.6. So it really goes around there. As you can see, the chip does max out, but honestly speaking, I can record this audio no problem. It's not even that loud. So I think I'm pretty happy with the cooling that we get. Also, it's highly unlikely we'll be pushing 32 cores at full speed at all times. It's more likely to be burst because most of the time we'll be using our GPU for processing. Also, if you look here, it's actually pulling 350 watts, no problem. That's pretty incredible. Next up, we're going to check out CrystalDiskMark to see how the drives perform. So in this example, we already have our two Kingston drives in RAID 0, so they're in a striped fashion. Just run them at their full speed and see how they perform. Again, the system is not really optimized for any specific performance. Also, it's running Windows, which has crazy overhead, but it should give us a slight bit of an understanding of what can we get. So these drives are running at a cool 48 degrees. That's pretty good. Considering they're running at full speed. With the drive results done, it's a bit insane how much technology has progressed over the last few years. We're seeing 14.5 gigabytes of read speed, and that's gigabytes, not gigabits, gigabytes, and 14 gigabytes of write speed. That's pretty insane, and that's going to be very helpful for our AI workloads as we get into them in a second. Really cool, and the drive never went higher than 52 degrees. Next up, let's open up LM Studio, and I've already pre-downloaded a few different models. Let me just open up a new chat. So a few models that I've downloaded are Llama, Quen, DeepSeek, and AI GPTOSS. Let's just start with that one. What I need to do here is obviously just select the GPU offload to make sure it gets processed on GPU. I'm just going to quickly load the model. So these models are currently stored on SSDs. So they're loading them up right now. And if I just move this one to the side, we can actually see that NVMe just shot up and kind of processed it all quickly. Now, the model is raised. It's not a big model, so let's just ask some sort of question. I'm just going to copy one of the previous questions I used. It'll be easier to see and generate something, just for keeping it fair. There you go, that's processed already. The processing was done at 113 tokens per second. That's pretty incredible. Let's change the model and change it over to a larger Llama model, which is a 3.3. Again, I'm going to max out the GPU, but in this example, it's actually not going to be able to put all the data into the GPU VRAM because the actual model is way bigger. I believe the total size for this model is around 45 gigabytes. So I would need 2 of these cards, but we should be able to get some of it in and just run it together between the GPU and the CPU. That's loaded. So I'm just going to run that same task. So I've already tested it earlier and it's a lot slower for obvious reasons. There you go, the GPU is running 100% now. And as you can see, the memory got filled as well. So it's offloading part of it into our memory and it's getting the work done via the GPU. But some of the data is being kept on the memory from the CPU and still being processed by the GPU. So the GPU is doing all the legwork, but unfortunately can't hold the whole data inside there. But it's processing it. It's a bit slow, but definitely processing it. That's the test done. So in this example, it was doing it at 2 tokens per second, just over 2 tokens per second, which is 50 times slower. And that's mostly because the VRAM is filled up on the graphics card and it can't actually process it all in one go. So the data has to go between it via the CPU to the memory and back and forth, which is an issue. And that's something that we want to address. This is just a quick overview of what the system can do. It's a quick throw together system. What I'm going to do next is set up a proper Proxmox server. I'm going to virtualize it. I'm going to set it up and test with both 3090 as well as 7800 and see what kind of performance I get, which models work better on AMD versus NVIDIA, and basically start optimizing the system because there's actually a lot I can do here to make it faster, smoother, and hopefully smarter. We'll get into that in this next video, so make sure to subscribe so you don't miss it. If you want to check out any other items covered in the video, we'll leave the links down below. We'll see you guys in the next one.